All right, let's get this going. My name is Patrick Huck. I'm a computer systems engineer in Christine Pearson's group. My background is in high energy nuclear physics, actually, so we have quite some variety in our group, as you can see. I'll be talking about our new contribution platform that we're trying to make available and have available for users to contribute their own data and have it show up on Materials Project and also expose it to our over 130,000 users. The first half will be a walkthrough of the contributions framework in general, how contributions show up on Materials Project, and the portal that we've developed to actually browse contributions and discover them. We'll have some exercises that let you get familiar with it and find your way around. And then the second half is we're going to go into a notebook and actually contribute data to a sandbox project, or maybe at that point you'll have your own project. That data is prepared for you and comprises data on reflective index. And by the end of that session, you should have been able to see data appear on Materials Project. So let's go head over to Materials Project and load up the Explorer. Let's say we're looking for materials and we're browsing around, and one thing I could be interested is maybe cobalt or arsenide, right? So let's look for those elements. Gives me a few that have band gap, so I could take MP2715, be interested in that. Some of this Matt Horton has shown in his walkthrough of the website, and he's also shown that at the top there's these tabs that take you to different parts of the Materials Project detail pages, and one part of those components is user contributions. So if you click user contributions, it'll scroll down for you all the way to the bottom, where you can see user contributions that are already existing in MPContribs show up as what we call contribution cards. These cards basically reflect one set of data that is linked and associated with one material, in this case MP2715. And what you see here is a title for that data set. I call those projects in MPContribs. They link, as you can see on the bottom left when I hover over it, they link to a landing page for this data set. There is references that the contributor can decide and add to the project information, and usually people use DOIs to papers or their database here. If you click at all, you'll see all the authors that were involved with that data set as a description that can have a little more details. And then what we currently show in these cards is the simple key value part of contributions. So this could be just names and numbers for things like band gaps, corrections, experimental values that don't have a dependency like spectra and other things. Every contribution that is associated with a material like MP271 can include these simple data, but it can also include tables and structures, PyMatrix structures. So we'll get to that later when we browse the portal. And the details button here takes you to a specific landing page for this single contribution on the portal. So I'm gonna click on the landing page, on the title for this contribution, and this will take me to MPContribs, which is a portal where we collect all the contributions that are currently available to Materials Project, and which you would use as a contributor to prepare your data and highlight it to our users. So we've come from a detail page in Materials Project, which would be one single row, one entry here. The entry that we came from is MP2715. So that's the one that you can see show up here. And before we go into details of what this landing page for this data set looks like, I want to take a step back and start with the MPContribs platform in general. So I just clicked on the logo in the upper left. When you do that, you'll get an overview of all the projects that are currently existing in MPContribs. A side note, we've recently restructured the data a little bit. So some of these need re-uploading, and we're working with our collaborators to get data up there again. You should be able to find data in the defect genome, PCFC projects, the band gaps, the carrier transport, the screening inorganic PV, the QSGW band structure, Jarvis DFT, I think there was a question about it, has a large data set that is complementary to what we have on Materials Project, and the same with 2D Matpedia and the MNO2 phase selection. And as you can see, I've prepared a sandbox project already that we'll use later to add our reflective index data to. As a side note, interestingly, 2D Matpedia, for instance, has prepared their data set as part of their publication. So when they were writing the paper, the idea was that the data that they added to Materials Project here, they would use as a link, as a reference in their paper. So portal.mpcontribs.org 2D Matpedia would actually be something that you could reference and point your readers to in case there's updates to your data set, or if there's things that should not only live in your supporting information of the paper. So how do we navigate the site? In addition to some preview images that you can see when you click on the project image, you can use the navigation bar, the drop down in the navigation bar, to either scroll and quickly jump to one of these landing pages that I've just talked about, or you can actually search the descriptions for something. So you could say I'm interested in phase selection. So this would be for projects that have the word phase in their description. Or I could look for transport data. That would be those two. Carrier transport is one of the bigger data sets that we have. So that would be all under the Browse tab in terms of a list of projects that you can look at. In the future, we'll maybe include here sort of a leaderboard, include the number of contributions that are in a project, a better overview of what the details of this project entail and how much data is there in our MPContribs databases. The four tabs at the top are important. Those are basically all the four things that you can do with the platform. We talked about Browse. Let's look at search. This is a small search interface that can look for entries across projects. Again, same procedure. We could basically say look for carrier transport. So this gives me a quick overlook of the contributions that are in this data set, including the formula, the specific contribution, and the MP ID for it. The link, this link on the right, in the right column, takes you back to the landing page for this material on Materials Project that we just came from. The ID on the left is an ID for this specific contribution, and you can see you can just go through and click them and look at the according cards, contribution cards on the right, and you should recognize those, albeit the different styling, from the materials detail pages. So the information you get here in terms of title, the detail for it, the description, and the simple data in terms of key value is the same that ends up on the materials details pages. We could also look across formula here. So we could, for instance, say, let's look for our cobalt artisan. Let's just look for anything cobalt here. Maybe I can find one that I was looking for. Yeah, let's look for this one. Yeah, there is one in the DTU data set that is band gaps on this material for MP2715. So you can see that there's many roads that lead back and forth between MPContribs and Mathilde's project. And either way, either coming from the landing page of a data set that you've contributed or coming from Mathilde's project will lead you to the same end results. So you can just use identifiers to search. You can also ask whether the contribution has structures or tables in it. The next tab at the top is apply, and that would basically, for anyone who's interested to put their own data up on Mathilde's project, would be a starting point for their project. And you'd basically fill out this form, give me a little information about what you want to call your project, what short title would be that is on the homepage of MPContribs, a longer title for the landing page, a little description, and then at a minimum one reference where most people use DOIs. And if you hit the apply button, you'll basically send out an email to me with your information, and I would have to approve it so that you can start putting your data as onto the platform as part of this project. So the idea here is that anyone who contributes to Mathilde's project gives it a little thought, what data they want to put up there, what data makes sense to put up there, and send that information my way. I will leave this to our exercises for the first part, where if you have an idea or if there's data that you want to put up on Mathilde's project, you could go ahead and fill out this form. And if I have time and see the email, I could approve a few. Moving on in terms of the tabs, the last part is what I called work. And there is documentation, better documentation coming up, but in terms of executing code, and if you feel comfortable reading Python code and executing Python code, a lot of which you're learning in this workshop, you can look through existing examples of how other people have used the API for MPContribs to upload data. So again, this is sorted by the projects, and shows you the code that you would have to execute in terms of getting data up to Mathilde's project. And the final piece on the MPContribs portal would be a little extra information. There's a link to documentation, and we're starting to build up a tour for this page. The API key is a button here that lets you copy the API key for the MPContribs portal. As of now, that is different from our official MP API key, since the infrastructure is separate in the backend, but we are looking to combine that in the future. So if we're later talking about an API key, this is where you would find it. For anyone who is interested or needs more information about the API, there's a link to the RESTful API that is dedicated to MPContribs, and you can see that it has the same parts that I've just talked about. So every project has a list of contributions, and every contribution can have a list of tables or a list of structures. We'll see more about this in our second part of the lesson. I just want to point out that in addition to using the Jupyter Notebook help that you've learned about, Shift-Tab, you can also check out documentation here. And on the right, the get entry, update entry is the equivalent of this operation in the MPContribs client, Python client that we're later using in the notebooks. And you can also, if you enter your your API key in here, you could just go ahead and test out a few API responses live if you wanted to. I don't want to go into more detail here. I just wanted to point you to that API as a source of information. Okay. So I think I would leave it at that for an introduction to MPContribs as a platform. As exercises, I thought we could give you time first to make yourself familiar a little more with the platform, look at the data sets, use the search tab maybe to find some interesting contributions. and look at their detail pages, get a feeling of what data in MPContribs looks like, maybe compare it with what data you have in mind to put on materials project and how that would look if you did it yourself. And you can scan the notebooks on the worktop a little to get a feeling of the code that we'll later execute in our second session. And if you feel inclined, feel free to fill out the project application and send an application my way. I will also monitor Slack, and if there's any questions coming up, I'll try to answer them. So let's take 10 minutes, 5 to 10 minutes for you to browse around and make yourself familiar. Yeah, so maybe I can chime in here because I'm seeing already very good questions in the Slack. One question is there a link from materialsproject.org website to get to MPContribs? That's a very good question. We haven't put it up somewhere prominent yet, but I think a good place would be either in the sidebar to ask for contributions that for materials that have contributions, so you can filter that way, and then take you to the according entries, and we'll also add something at the top of the page that links to MPContribs. So it will in the future. Another comment is MPContribs seems to be for large data sets of properties, small or large, both is possible. Large is relative in the sense that we're interested more in high-level data that goes into papers and is basically ready for dissemination. It can be experimental, it can be computer theoretical. There's no restrictions on that. In terms of individual structures, you're right. You can either upload CIFs to the Crystal Toolkit and submit them. What you'll do there is basically suggest that structure for us to calculate it, and we'll go ahead, submit it to our infrastructure, and then add it to our core entries. So that material, that structure, if it ends up being a new material, it will end up with its dedicated materials details page on materials project. You still have the option in addition. So for instance, we could look at the MNO2 phase selection project here. That project on MPContribs not only has simple key value data in terms of, okay, it's a crowd state or not, what are the enthalpies, it also has structures that you can add, and they can be different from what the original MPID points to as a structure. So basically, depending on the application that you have and what you want to do with your structures, you have both avenues available to you. Do we need to install MPContribs package? Yes, so for the second part, you don't need to do it today. It's all installed in CoCalc, but to talk to the API through Python after the workshop or on your own, all you need is the MPContribs-client package. And I can pull this up here. So basically, you would just go and do a pip install of the MPContribs client and then take it from there. Is this project complete? Like, yes, so the Fe iron, cobalt, vanadium data set has been around a long while. I have to re-upload it now. It's one of the projects that I've had to scratch a week ago or so because we were changing our data organization in the background, but it will be back soon. Is MPContribs capable of ingesting data that is useful to the synthesis community, but perhaps not useful to the calculations community? I would say yes. It depends what synthesis data would be. I think in most cases, if it fits into a here's a table, simple values and structures, then yes, MPContribs would be able to take care of that too. And yes, in terms of building an interface between the two, we have, I think, active learned IRO polymorphs is with Slack. They have their own interface, but another example would be Jarvis DFT, which basically links data on materials project with entries on the Jarvis DFT platform. So one thing you could do here is, as part of your contribution, link that entry to a detail page that is on your end, right? So we won't be taking all of the data that is necessarily part of what you've calculated or what you provide on your own interface, but we would definitely point our users to it and give credit that that's where more data can be found. The same is true in the 2D Matpedia project, where we're pointing to the 2D Matpedia website. So they basically have some of the information that they posted to MPContribs is also available here, but there's also density of states and other things that we didn't upload to MPContribs. So depending on the application, there's a decision to be made. Which parts do we want to prominently show on MP, and those should go into MPContribs, but other things could be linked out to your own landing pages. All right, those are very good questions, though. So since we're all a little more familiar now with the interface, I hope I wanted to go into a little more detail of what a landing page would look like, and what the features on a landing page are. Let's stay with 2D Matpedia. This is fine. So basically, once you start uploading data through the MPContribs client using Python right now, they'll show up here and it'll update right away. You can do automatic filters on text-like entries in your contributions. So for instance, the formula, or in this case, the details. Maybe let's switch to MNO2 face selection. An interesting case, for instance, here is the ground state column, like has a yes or a no. So we could go and ask for a ground state for all the things that have a Y in it, and filter. So that would give us the ground states. And this is out of the 88 that are in here, 18 of these contributions are in the ground state. We could also select the columns and say, yes, we're interested in, actually, we don't want the structures right now. I just want the enthalpy in the ground state column, and I want them sorted by enthalpy, right? So that way I can get a quick overview of what my project or this project looks like, and what specific contributions that are interesting to me would be. For instance, that if I click on 18767 here again, I can go straight back to the materials details page for it, and there's going to be the user contributions. Took a little longer to load. And the contributions for it should show up on the details pages. Another feature here in terms of details for this contribution, as we said, the structures are shown in the table too, and you can download them. So if I clicked on one of these, it would download a ZIP file for the structure, but you can also click on the row number and get details with code that way. So that's a different representation of that row that shows you code of how to get this contribution through the client. So in the upper part here, we have the simple data that's part of the contribution, and then there's the structure that was submitted with this contribution. Additionally, you can let's select the columns that we're interested in again. You can download those two as JSON or CSVs, and take that table into your analysis framework of choice. That could be Pandas or others. So those are things that all happen automatically when you upload data. One thing we're envisioning in the near future is that we extend this to interactive graphs that let you select certain ranges for specific columns and graph columns against contributions and materials identifier. So stay tuned for that. All right, so for the second part of this lesson, as I said, we would want to go into a notebook and see whether we can upload data that I've prepared about the refractive index. It's from the refractiveindex.info website. And while you're getting ready, you could either check out this database website, and we'll go back to CoCalc and find the lesson. So right here, I'm in the root folder of our CoCalc, and we'll go to workshop and lessons, and number 07 MPContribs as one notebook. The contribute notebook has all the code filled out. Feel free to follow along or start a new notebook, which we'll use to do a few things on our own. So as I said, and as somebody has asked, we'll be using the MPContribs Python client for this. It's a straightforward pip install as a Python package index package, and we'll use data that I've prepared in the MP workshop library, and we'll import it. So we'll save a little time in terms of preparing our data for submission. But we'll explore that data, and you can basically use it as a template to think about how you would structure your own data. So let's get the data first from MP workshop.mpcontribs import data. And then also, when that's done, we'll get our client from MPContribs.client import client. And you should be recognizing here the parallels to how we use the MP rester. So MP rester is a Python client to the MP API, and the MPContribs client is a Python client to the MPContribs API. So once that works, we'll basically set up our project and our client. The first thing is, as I said, I've set up a sandbox project that we'll use to add data to. And I've also generated an API key. So if you are following along live, I will post a API key in the Slack channel right now that you can use and gives you access to the sandbox project. So we'll all try collaboratively to put data into the sandbox project. So what you'd be doing is copy that API key from Slack, and then initialize the client with it. All right, so let's say we want to take a look what that project looks like right now. If you check out the help for the client, I shift tabbed just now. You can see auto completion for it, or you could try, as Sham has alluded to, you could try the dir command on it, which would give you the resources that are available in this client. So I've shown you these resources on the API documentation page. There's a resource for projects, resource for contributions, for structures, tables, and notebooks, which are automatically built. So let's take a look at the projects. One thing I want to do first here is use a convenience function, which is called getProject, that is part of the client, which takes as an argument the project name, and it'll show you a nicely rendered HTML table that contains or can show you the table that contains the data. So with just get project, you get all the data as in a dictionary format that's in this project. And we can append .pretty here, just make it a little more legible. So this would be the data when you apply for a project on the portal. You basically fill out these entries here. Is approved will be set true by me, and only if it is approved you can put data in. So just applying for the project alone will not let you submit data. There's a description that you can enter. The references will be there as label in the URLs, and you also notice a columns entry here that is basically a list of columns in your simple data that will later be used on the portal to define ranges. And it's something that MPContribs automatically sets and keeps track of when you submit data. As there is already a little data in the sandbox, these column values are already set. And you can see it gives you the unit for it, and it gives you the path, the nested path indicated by dots to every entry in the data dictionary. It also contains whether there's tables or structures in this contribution. Okay. One additional comment that I would want to make here is the unique identifiers flag is a flag that we use to indicate whether every contribution in this project belongs to, can only belong to one MP ID. So that means that every MP ID or materials identifier is unique in this project. This is important for duplicate checking and so on. So if you can separate your contributions as contributions to separate materials or materials project, this unique identifier would be true, and it is by default true. That would avoid that you accidentally upload duplicate contributions or different data for different materials identifiers if that's not intended. There are applications and projects which are submitting multiple contributions, and they're all valid for multiple materials. And in that case, you would set unique identifiers to false. I've done this here too, because we're all collaboratively submitting data right now, and that might mean that identifiers are colliding. All right. So as I've said at the beginning of this lesson, there is a data dictionary that I imported. Let's take a look what's in there. It's basically the refraction index data that I've prepared for you. So if you look at data.keys, it'll show you a list of names that I've extracted from your email addresses when you signed up. Maybe find the one that is yours. In my case, that would be Huck. And if you choose one name here, I will just assign that to a variable called me. Let's say me is Huck. And I'll take a look at the data that is in there for me. As you can see, every entry here for a specific username would be a list of contributions that we've already prepared. So you see there's an identifier in there, there's data in there, and there's tables in there. And it keeps repeating, but we can drill in a little more to kind of learn what the structure of the data that we're submitting would be like. So let's look at the first entry here and its keys. And that's basically one of the important lessons already. When you prepare data for MPContribs, there is essentially 4 important root keys in your dictionary that you need to be aware of that are special. One is the identifier, which links your contribution to a materials project MP ID. Then there is data, which is hierarchically organized, simple data in key value form. You can nest the data to a certain level, and you can have a certain number of entries that is, I think, boils down to 50 columns in your landing page. So there's some constraint on the amount of data that you can put in there, and the idea for it is that anything that is in data will show up on the landing page as a column for a specific row. And the two other components of every contribution are tables and structures. So tables would be a list of Pandas data frame tables. I think Rachel has mentioned them in the previous lesson, but we can take a look here again. Say we're looking at this first contribution again, and let's look at tables. You can see that this is a list of tables. So if I'll take that first entry and maybe check its type, and I'm jumping back and forth with Control A and Control E, but I'll give you time to type it too. You'll see that the type of this is a data frame. And the same way, if you had structures, either in sieves or in POSCARs, you could convert them into PyMagen structures and then add those structures as to the structures key in your contribution. So all of this is already prepared for you. I want to take a closer look at the data that's in here. So I would go data, me, first contribution, look at the data and its keys. So basically what we've prepared here is just a simple set of key values. One is the type. Those are keys that you can choose, delta, lambda, and the coefficients. So for refractive index data, it basically means which type of formula it is that was chosen for a specific wavelength range that this formula applies, and the coefficients that were in that. And we're going to use that data to put it up on Mathilde's project. So we've talked about identifier data, tables, structures that make up a contribution. One thing that is missing is which project this belongs to and whether it's public or not. So what we'll do is just a quick loop over the data in our over the contributions in our data. So for contrib in data me, well, I'm basically going over the list of contributions that I've prepared for you. I will set the project key, which is also special here, to the name of the project, which is Sandbox here. So that basically means this contribution belongs to Sandbox. If I set something else here and try to submit it, it would not let me because I would not have permissions, or the key that I shared with you would not have permissions to contribute to any other project. And then contrib is public. So the second key that we need is indicates whether this contribution will show up publicly or privately first. By default, all contributions are private. So if you don't set that key, only the owner of the project, which in this case is anybody associated with the API key that I send around, but the API key is usually unique to you, and you would be the owner of your project. You would be able to see your private contributions, and you could ask me to add specific collaborators to your project, and that way you could prepare your data and your contribution and the landing page for Mathilde's project in preparation for your paper. So that's usually the timeframes we're looking at. Somebody is interested in bringing out a paper, and they would like to use a MPContribs landing page as a reference, and until they've released the paper, their contributions would be set to private. And after I'm done looping, I just want to check how many contributions are in there. Okay, So in my case, this says 2. There's 2 contributions that I'll be submitting. In your case, if you chose a different name for or a different value for me, you would get a different number here. Okay. So we're ready to submit now. I've talked about the structure. It's prepared here for you, but I think you can imagine how to take your own data and hopefully come up with a sensible representation that fits into data tables and structures. What's left to do for us is to use the client and a convenience function, which is called submit contributions. So all this function does is talk to the API and take every contribution that is in the list that we give it and upload it to MPContribs. So what I would do now is execute this. One thing I want to do before that, though, is go to the landing page for this project. So we'll go to the portal, go to the sandbox. I can see that some of you have already executed, which is great. Yeah, so I think my 2 contributions would be the 6134. Once I submit this, it will likely complain that the structure or the table that I'm submitting here, what's E, is already in here, right? So let's see what happens when I actually execute this. And as I said, tables overall should be unique too. Yeah. So it tells me that 18 contributions were already submitted. So some of you are already well along. Yep, there's stuff coming in. That's nice. But it also tells me that this table is actually duplicate. So I've submitted that before. What happens internally here is, even though materials can point to multiple contributions can point to multiple identifiers, multiple materials identifiers, the tables in it are still duplicate checked. So when it says it's a duplicate, it means exactly every value in that table is the same. So which is fine. This is just the illustration purpose that duplicate checking is actually happening, and I've submitted my contributions before. I can see that it's working for other people right now. And the more you do this, you'll see that number go up here. So we've gone up to 28 contributions. We could see if we go to MP 1070 now and looked at the user contributions. So what you'll see now is MP 1070 has data from Jarvis DFT. I've talked about that project, but it also has data from the sandbox. So you can see that some of you have used this data, and there's an entry for each that shows up. Some of them have delta lambda coefficient and different values for it. So you can see that this is a type F2 function with slightly different values for the coefficients, right? That's the only difference here. And there's 3 where for some reason the function of that index, refractive index, is actually not known. So one thing we would probably do here in a second iteration is that we clean this out, because we wouldn't want to, if the function is not known and we don't have any coefficients, we might not want them to show up at all. But this is a good demonstration of how you would start and then iterate of what you've done. And the last thing that I want to do in the last couple of minutes before we do some exercises is show how we could actually query this data. So we've submitted it. We could now, each of us could basically look at our contributions, and we could say, okay, I'll ask the client again to get me the contributions, client.getContribution, client.contributions. That directly talks to the contributions resource in the API, and I'll ask it to, and completion should work here basically. So if you ask for a specific resource like contributions or projects or tables, it gives you the endpoints of what you can do with it. What I want to do right now is use get entries to query for certain things. You can do download entries, you can do, which generates a gzip format, either in JSON or in CSV, or you can update single entries or multiple entries, delete entries, and so on. For now, I just want to demonstrate querying it. So we'll use get entries. And the get entries basically returns a response that we need the result for too. So this is basically the standard format of every client call, unless you're using a convenience function like submit contributions. This is how you would talk to the API through Python directly. So once we run that, you can see that we're getting a response with some default fields selected. There's a total of 4,800 contributions right now in MPContribs. You only get the first page of about 20 and only the default fields. So one thing that I could do now is say, actually, I'm not interested in all the projects. What I want is the one that has our name. So everything in the sandbox. So we're up to 33 contributions in the sandbox right now, which at 20 per page would boil down to 2 pages. And the second thing I could ask for, well, I know my identifier actually that I've contributed, so give me everything that's MP6134, right? And that boils it down further to the 2 that I actually submitted. Still only the default keys for it, but the 2 different contributions. And right now, I'm only seeing default fields returned. So ID, project, identifier, formula is public. Those things get those fields get returned when I just ask for a default query. But I can use underscore fields to actually give it a specific list of fields that I want to be returned. Right now, all I want is the ID, which is this long number, which identifies the contribution across all contributions. So I just want those. All right, that looks a lot better. And I want to, I'm going to assign this to a variable. The reason I went that way is I want to look at one contribution specifically, and I want to show how to basically pretty print a contribution. What I can do for it is let's get one of the identifiers that is in this response. So I could contribution ID is equal to let's take the first one in the first return contribution in the data key. So when you run get entries, all the contributions that fit that pattern and fit that query are going to end up as a list in data. I'm going to look at the first one, and that should have an ID key because that's all I asked for. Yes, so that gives me that identifier. And I could use the client's contribution convenience function to just look at this contribution, everything that's in it. So I'm just cutting across a little here, different ways of getting at the same things using the client. If you use the get contribution for a specific identifier, you will get the entire response, and it'll point you to the tables and structures that are in this contribution. You could have gotten the equal response by using the naked get entries and setting the fields right. So I'm going to assign this to a variable, and I want to look at it a little prettier. So that again would show you what's in this data set, the type, the wavelength range, and the coefficients for this contribution, and it'll also show you the ID for the table that was in there. Okay. The last couple of things are taking a look at this table. So basically, the contrib tables entry has the ID for it. So I could say that my table ID is now contrib tables. Let's take the first table in there because there is only one table and I want the ID for it. That will give me this number here, 5F22F or string, and I will ask the client to get that table for me. And you can see that this looks very much like a pandas data frame again. That's the part that we put in. I can check the type for it just to make sure. Yes, that's a pandas data frame, so I can go ahead and just do things with it that I would want to do. One thing that I could do, for instance, is plot it. Pandas data frame has an integration with Plotly, which makes interactive graphs. So if you append .plot, you will get automatically an interactive graph of your table in this contribution. That's zoomable and selectable and so on. So, okay, so we are 6 minutes out from 2 p.m. We've started a little on the querying. I would want to leave you with one last line of code, which is building up a little more difficult query. So let's the way I would write this is basically define a query dictionary, get the contributions resource from the client, ask it to get entries for me, and use the query for it. So you should recognize that from the previous cell that we executed. It's the same pattern. I'm giving a query to the get entries function, and I'm asking for the result. So without any query, I'm getting the same response again with everything in it, just the first page. But I could be a little more sophisticated here and say, okay, again, I want only our sandbox project. I want all the things that, and I'm going over this a little faster, but as part of the last 5-minute exercise, you guys can try out a few other queries yourself. So I could go formula contains, say, lithium. I could ask if the data type, so the formula type that I've submitted as part of my data entry, I could ask that this be the function for. So that's something that you've submitted yourself, and it's being indexed and queryable through the client. And I could ask data coefficients. So coefficients is another entry in the data component of the contribution. I'm asking for the first coefficient and its value to be greater than equal something. Let's do 0 for now. And I will also set the fields and ask for ID, identifier, formula. I want the data type that I queried on, and I want the coefficient value for C1. So that query alone should give me the 2 that I actually submitted. That's how it was targeted. I submitted something on lithium. And I can be a little more specific now and say, well, actually, I want only one of those. So my value should be larger than 0.00493 or equal. That would boil it down to 1. So that way you get your data queryable and organized, and it shows up on Mathilde's project, and in a way that I hope you can envision for your own data set. And I would want to leave you, if you're going back to our exercises in the last few minutes, scrolling all the way down on the workshop. yeah, basically you could take a look now at the carrier transport data set or any other things that you're interested in and build up queries that would allow you to find certain things. Maybe use that carrier transport data set to get a display and plot it interactively. If you've applied for your own project and you could use this refraction index data to put it in your own project, or you could start adding your own data to your project. And I've also on the workshop page, I've shared an invite link to the MPContribs dedicated Slack channel. Yes, so that would be it for the lesson. Feel free to just follow these exercises, and then we'll go into a break. We'll also monitor the Slack channel for any questions that you might have.